n would be, or like the amount of operations would be the smallest, because it's four. It's four, and for the second, for C it's four. For if let's take n as 16. For C it's four. For B it's 8, and for A it's 16. So it's going to be C. Let's take.
Yeah. So what is your final
Hello?
answer? Yeah.
So my final answer would be C, because
Yeah.
and the fourth one is infinite.
Yes.
Okay. Okay, 1 minute.
What
What
is time complexity
the
of the
complexity?
following?
Yeah. Okay, the time complexity of the following code: integer a equals 0 and I n, while n is greater than 0, we what? A plus equals I. Okay, we increment a, which is currently 0, by n. Interesting. So we increment it by n, and then we divide it by 2. And then starts again. So it's gonna be n divided by 2, n divided by 4, n divided by 8 and 16. Oh, again, I think it will be infinite, because it will infinitely try to. It will always be greater than. There's always going to be a little bit that can be divided by 2.
No, because uh, here I is integer.
Because here I is integer?
Yeah.
I didn't hear.
So I is integer. That means that it will it won't be so for example I is 4. Can you iterate what will be I each time of the iteration?
It's going to be 4, then it's going to be 2, it's going to be 1, then it's going to be. Okay, so if it's integer, that should stay at 1. Then
No.
Okay, so the next iteration, when it becomes 1, it will try to do 1 by 2, and then it becomes so it's going to be how do I say it in English? This division without the remainder, and this division without the remainder will be 0.
Yeah.
Okay, and so we'll have 3 iterations. It's going to be it's going to be okay. It's going to be 2. It's going to be 1, and this. So it's 2 iterations.
So it's called floor division. And
floor division. Okay.
And the result will be how? What will be the time complexity?
Okay, the time complexity would be then, if it's division by 2 every time, it looks like log n again.
Yeah.
Can I say that? Log n? Okay.
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 So there are few different categories. Oh, actually, can I choose sort of like Java? Okay, but I hope you will understand. So when we're talking about time complexity, you can have three cases. It's average time complexity, worst case time complexity, and best case. So here it's asked for worst case time complexity. And what do we have here is a vector, which is like array list, and int k, int start, int end. So this is an algorithm. Do you see it clearly?
I see it, yes.
So you need to understand.
Okay, so there is kind of an array list of integers. Then there is also three different integers: k, start, and n, or like three different ints. And then if start is bigger than n, we get 0. If int mid, okay, we create a new integer mid. If it okay, and we assign start plus and divided by 2. Okay. Then if v of mid is less than k, some other, okay, so if what? So if the number at so if the number kind of between start and end, if the element of this array list at the position, at the middle position, is less than k, the return search name, search number occurrence. Okay, so it returns the recursive function of itself, kind of.
Yeah.
So if it returns the recursive function with the same vector, with the same k, with this mid incremented by 1 and with n. Okay, so it kind of goes, or like steps from the middle to the right. In this case, in the middle to the end. In this case,
Yes.
as long as wait, isn't it like a binary search?
Almost, because here you have
Okay.
yeah, almost binary search.
Okay, so we set start and the end, and then we give the int k, and we kind of want to. Okay, so for the right part of this array, we want to find where that is. Okay, so it's gonna, the recursion will work as long as we have all the numbers less than k, and then when it finds the number that is bigger than k, then it's gonna return. What is it gonna return? It's gonna return nothing. It's gonna just jump to return search name occurrence. It's gonna jump.
Did you understand what this algorithm is doing?
So for the right part, it's searching for the biggest, for the int greater than k, the if the mid is greater than k, for mid is lesser than k, middle number is lesser than k, then it's going to go to the right and search for something that's bigger than k. If middle number is bigger than k, then it's going to go to the left as long as it's going to go to the left as long as we're made, as long as the number is bigger than k. So it's going to search for this, for the smaller number than k. And so the search number is 8. Goes. Okay, we give it to we give it to k. The start will become a plus 1, and end is just and the second one, the start remains the start, and the mid minus 1 is our end. Yeah, so in the first, so if start is bigger than end, return 0, because it cannot be bigger than, it shouldn't be bigger than, and should be bigger than. Okay, then we check this. This first condition is just to check that we have kind of the right, I don't know, the right start and the right end. Start should be smaller than end. And the next one, we just get the middle point between them. Then the next one, the next condition, in the next condition we will search for any number that is bigger than k.
It's actually not right. So what this function returns?
It returns it returns itself.
No, I mean this function. I call it with some array list. For example, it will be 1, 2, 3, 4, 5 up to 10. I pass.
It returns as an integer. So I guess it returns the smallest if mid is less than k, or like as long as it's less than k, the recursion will keep going. So it's gonna return the maximum in or from the right part of an array.
No.
It's gonna return the maximum, not the maximum.
No. Just see what is returning here.
Oh, okay. Return search no occurrence. We k start made minus 1. Okay, so it returns this function. Plus, I don't see, plus 1, plus search, no occurrence. Can you go to the right, please?
To what?
To the right.
Oh,
I want to see. Plus 1, plus search, no occurrence, we came in plus 1, and So the start will be, so it will be the maximum. the maximum number from the right and the minimum number from the left, and they will be added.
Why do you think search num occurrence finds the maximal number or the minimal number?
Well, okay, in the first condition, as long as the b as the middle element is less than k, so as long as it's less than k, it will go into the next step of recursion, and it will start
Mm-hmm.
at the position mid plus 1.
So why do you think?
It will start.
Yeah, I get it. But
What?
why do you think the function returns the minimal element? Yes, it goes to the left as far as mid element is bigger than k.
But it goes to the. Doesn't it go to the right?
Okay, to the right.
As far. Yeah, okay. It goes to the right as long as the element is smaller than k.
Yes, less.
Less than k.
Yeah. So.
Yeah, and when it reaches some element that is bigger than k, then it goes. Well, it stops.
No.
I don't know.
No.
It doesn't stop.
When middle element is bigger than k, what happens?
Okay, when middle element is bigger than k, well, it will jump to return. It will jump to return each time occurrence we k start mid minus 1.
So, what I'm
No.
When you say the function calls this, you say function goes to the right. But why, when you say this function is called, you don't say this function goes to the left?
Yeah. So the upper function will go to the right, and the lower function will go to the left.
Okay. So question is, when it stops?
So lower function will stop when the middle element is more than k, less than k.
No, it doesn't stop. It again starts calling itself. Right? If the recursion calls itself,
Sorry, I didn't hear.
If recursion is calling itself, it means it doesn't stop. It's going further.
Okay, so it will, but the recursion will go as long as
Let's actually do it.
Mhm.
So we have a code. So, for example, we are passing array 1, 2, 3, 4, 5, 6, 7, 8. And we are passing k equals 6. What will happen? And start and end initially equal 0 and 7.
Okay, so if start n, it returns 0. And so we go to the next thing. Then get the middle element, which will be so it's gonna be 3. So the element at the position 3 is int 4. And then we go to the next condition. And the next condition is if and is less than k and less than k, then return same function with the argument with the same array of ints. Okay, so it takes the same array of things. It takes 6. It goes mid plus 1, so it's going to be 3 plus 1. It goes to 5. It's gonna start from 5 to 8. Oh, okay, from 5 to 8. And then it's gonna repeat itself. If start is it's not, then mid will be start plus n divided by 2. Start here will be 4 and end will be 7, so it's gonna be 13 by 2. It's gonna be 6. The sixth element here will be 7, and if mid, which is 7, that is if it's less than k, and it's now it's bigger than k. So we jump to the next condition. So if it's bigger than k, then this condition stops and we go to the next one. Well, so next, if the mid is bigger than k, but in this case now the mid is 7 because it was assigned as 7. And now if it's bigger than k and it's bigger than k, return the function of itself. So v and k, okay, star is gonna be 0, and the end would be mid minus 1. And mid minus 1 would be element 6. So we're gonna element 1 to element 6. And if when I'm confused. So we, with the first, with the upper condition, we have reached 7, and we just nothing happened. Okay, and then we're going to the next condition, and now if the element is bigger than k, which it is, return search number occurrence array. V, it takes array, it takes k, and k is 6. Takes start, which will be 0, which will solve the element 1, and the end would be mid minus 1. Yeah. Mid minus 1 would be 6, so it will start it from element 1 to 6, and if now we now we get the new mid. So if it's from from 0 to 5 divided by 5 divided by 2, it's gonna be 2. So the second element is 3. So if the V mid, which is 3 now, is bigger than k, and it's not bigger than k, return search number occurrence. Okay, so in this case, this element is less than k. Element 3 is less than k. It's less than 6. So we go to the next line. Return search name occurrence. V k start, which is 0, and mid minus 1, and the last mid was 2. Mid minus 1 would be 1, so start would be at 0 and end would be at 1. So it calls for the function of itself from start position 1 to 2, from start 0 to end 2 and 1. No, I'm confused. What's happening?
Okay. So
we went through the first, yeah. We went through the first conditions without like returning anything.
yeah.
But it should have returned. I mean, we didn't return anything because at some point the condition is not fulfilled, and then when it's not fulfilled anymore, then it doesn't return anything. We just jump out of it.
No.
Right?
Sometimes.
No?
I mean, all branches of this function is returning something. For example, the fourth line returns 0. The sixth line returns something. The seventh line returns something. The eighth line returns also something. So it isn't.
Okay, but if the sixth line,
Yeah.
at the sixth line, at some point, the condition filled anymore,
Yeah.
and it starts being fulfilled, then we just move to the next line without returning anything, or what?
So if condition is false, it won't
Yeah.
happen. If the second condition also false, it also doesn't happen. And then third line will always execute, because third line doesn't have some condition. It always executes while two condition fails.
Okay, so it's kind of a three branches into which our recursion can
Yes.
go.
Yes. It's actually sort of two the same branches, just in combination. Yeah, you see, it's the same branch, which is called in the first condition, and the first expression here is the same branch like in the second condition. So it decides when only one branch of condition, left or right, or both of branches will go.
Okay, so oh my god, I've left at the point when we've skipped the sixth line, we've skipped the seventh line.
And we go to the eighth.
It's not fulfilled anymore, and then I'm going to the eighth line. What?
Nothing. I can try to explain how the function is working right now.
Okay.
So if it starts with 0 and ends with 7, so the function is called with k is always the same and v is always the same, so I will skip it. But what will I write here is mid plus 1. Okay, so the first call is with 0 and 7. So this call is dependent. Mid will be, I will write the mid as a third number. Mid will be 3. So this function, because the third element is 4, which is less than k,
yes,
it will call the same function, only now with mid plus 1, meaning 4, 7, and the mid for this will be 5. Right?
yes, yes.
Now we are looking at the fifth element. It's 6.
Wait a second. 12. So 4 plus 7. Okay, 11. And okay, it's gonna be a fifth element, which is 5. Okay, fifth element is 5.
No, fifth element is 6. So we have an array V, and indices are 1 less.
Alright. I was looking all the time at the first array. I didn't check that it's index, that you mean indices.
Oh, I see.
Okay. Okay.
And so it will be 6.
Yeah.
Meaning neither of checks will go. Yeah? It will go to the last line.
It's going to be 6, and 6 is equals 6, so it doesn't work, and the next check also won't work. Wait, will it not work? But okay, if it's not 6, then we go to the line 7. And
No,
at
no,
the
but
line
it
7,
but it is 6. Let's look at this.
okay, it is
option.
6.
And what we are going to do is to call both of functions, yeah, with v start 4 and mid -1, which is also 4, and we make plus 1 plus.
Wait a second. Returning to this 475. So when it's 4, so when it starts at 4, ends at 7, and the middle that we get is 5. So we get the element 6, and then we get the middle element 6, which is bigger than 6. It's false, and we jump to the line 8. Okay, and at the line 8 we start performing this summation with start at... Okay, so the last start was 4, and it's gonna... I'm a bit confused why the start is still 4 and not 0. So
Because previous start was 4, right?
so the previous but it was mid +1. That
Yes.
was... So mid was at the... So as at the first function, mid was at the position 3, which was actually 4. So the mid +1 was our start, but we don't assign int 4 to start. I don't see the place in the code where we assign 4 to start. Start is just 0.
No. So
Okay, at which point does start change from 0 to 4? Because
So
I
remember,
understand...
here we
Yeah.
have a stack of called stack, meaning
Mhm.
that we have several start variables, and here I represent this call stack. The first call star equals 0,
Mhm.
but on the level of the second call start already 4.
Hello?
So at the second call start is 4, meaning that when second call starts to call these functions, start is 4. It calls with second level start, which is 4.
Okay, so okay, so yeah, I have to think in terms of recursion. So the mid +1, which is 4, it kind of actually goes to the top and becomes 4, becomes the start. Okay, I got it. So it goes kind of higher, and it becomes start. Now it's a start, and Okay, it becomes start. And the mid would be taking from the previous call, which is 7, which is 5 minus 1, and it equals 4. Okay, so it's going to be 4. Start is 4, and is 4, and mid would be 4 plus 4 divided by 2, which is okay, plus 1 plus search name occurrence taking from the previous stack, and the previous stack here is 4, 7, 5. So it's going to take mid plus 1, and the mid was 5. 5 plus 1 is 6. Then the end would be 7. It doesn't change, so it's 6 and 7. And then 6 plus 7 by 2 is 6. Okay. So we will have the next stack for 2 recursions, one of which is 4, 4, 4, and the next one is 6, 7, 6. Okay, so we go here again. If start is bigger than end, return 0. It's not bigger than end, it actually equals. So we go to the next line. The mid is 4. Then if mid is less than k, it is less than k, we return search name occurrence. We return mid plus 1, which is 5. We return end, which is 4, and we return end mid, which is 4. So it's going to be 5, 4, 4. Right? Hello?
Yeah, I think.
So for the next step for
No, sorry.
so function
Sorry.
for
Yeah. That. What is the result?
5, 4, 4.
You mean the call to
F.
5, 4, 4, like that.
Yes. Yeah.
Yeah. Just one moment. Yeah, correct. And what it would result in?
And it will result in if the mid is less than k, if 4 is less than 6, it is less than 6, so it will result in mid plus 1 is gonna be 5. The end position will be 4. It's gonna be 5, 4, 4 again. This is weird.
No, it won't be. What would be start?
Okay,
and what would be end?
Okay, once again, if start is bigger than end, the start is 5. Okay, 5 is bigger than 4, so we return 0.
Yeah.
Okay, then 6, 7, 6. If start is bigger than end, and it's smaller than end, okay. We have mid, which is 2. Then if mid is less than k, and it's not less than k, it's equal to k, okay, then if 6 is bigger than 6, it's not bigger than 6,
No,
it
no, no, no.
equals 6.
No. What is mid right now?
6.
And what is the element at the index of mid?
Ah, okay, 7.
Yeah.
Mm-hmm. So, if mid, which is 7, it's less than k, then we go to the line 7. If 7 is bigger than k, it is bigger than k, return start, which is 6, then mid minus 1, which is 5. So 6, 5, and 5.
Which will be
Then 6 is bigger than 5. Which will be 0.
And here we will get 1, 0 plus 1 plus 0.
Mm-hmm.
So the function will return 1.
Mm-hmm.
Do you understand what the function returns?
Well, it returns int 1, but I
Yeah, I see.
didn't comprehend what it's used for,
Okay.
or
Okay. Yeah. Well, what do you think the name of the function means? Search num occurrence.
well, search occurrence of the number k. So I suppose it searches for the amount of times k is inside of the array.
Yes, exactly.
Okay, but I cannot. I don't think I can see clearly how it's being counted.
Okay, I see you. So let's, for example, say that we have sorted array, not which can contain multiple elements, like 4, 4, 4, or 5, 5, 5.
Yeah.
And let's describe what we are doing with words and not with code. So firstly so first condition is hard to describe with words. Let's say we have start in end, which is left and right number, index of these numbers. So what we are doing,
once again, I didn't hear.
we can say that start and end is
Hello?
hello.
Yeah.
So start and end is boundaries of the array that we are processing. Yeah, so from the beginning it's 0 and n minus 1, and it gets smaller each time. So
Can you repeat like last maybe 2 or 3 sentences? I have problems with connection.
let's say start and end is boundaries for our task of the array. Yeah, we
Okay.
start with 0
Yeah.
and n minus 1. It's the largest boundaries, and each time they get smaller. So
We start with 0 and minus 1.
n minus 1, n minus 1. Like end is 7, which is 8 minus 1.
Ah, okay.
And
Why do we use minus 1?
it's in the task. Like in the task we have by definition that there is n minus 1.
Okay.
Yeah.
So n actually n minus 1.
Yeah. No.
Okay.
Not n.
No.
N is not n minus 1. N is n. And is n minus 1. Or did you say that?
So and begins as n.
Yes. Yes. Correct.
Yeah. Okay.
So, and what we are doing? We are saying, okay, the middle element is lesser than k. Then to search for this number, I need to go to the left side of the array.
Why left, right?
Oh, right. You're
I think.
correct. Yeah.
Okay.
And if
so
middle,
I need to search. I need to search for key elements, so I'll go. So I'll go. Hello? Hello?
hello?
Hello?
Yeah.
Hello?
I hear you. What do you say?
Yeah, I hear you. Yeah. Okay, once again, get some number that you want to search for.
So if middle element is lesser than k, then we are searching at the right side of the, right?
Yeah.
If it's bigger,
Yeah.
we search in the left side.
Yeah.
And if it equals,
Mm-hmm.
that means we find one instance, one occurrence of the number.
Mm-hmm.
So
Yeah, right.
we know at least once it's occurring. So what we need to know, how many times it occurs in the left side and how many times it occurs in the right side.
Okay, so when it finds this exact element, it will return one for sure. But also it will start searching on the left and on the right side from this number.
Yes. In case there are additional occurrences of this number.
Yeah.
So this implementation is bad, because if we have sorted array, oh no! So I need to understand. So it works.
So
not
it will. Yeah, I think I kind of understood it. So it will find the element in the middle, and if it's not this number, okay, first it will check the left part. Oh, okay, no. It will check whether the element in the middle is this number. So if it's not this number, then it... Yeah, it's weird because its implementation supposes that we will use sorted array, right?
No. Like for binary search, we also use sorted array, so it's okay. The weird part is that you don't need recursively. When you find a number, your number, you don't need to recursively call. you can just go to the right of this number and to the left of this number and count how many iterations the same number will be. Wow, that's my graphic card. Or maybe it's your internet. No, actually it's showing for me like it's okay.
For me, now it's okay.
Oh, okay. Okay then. So how I would write it? I would say then here, like for int e equals mid, e less than end, e less than equal, e plus plus, mid plus 1, if v with index I doesn't equal no, let's say equal k. Yeah, let's write it like this. So I would say I will have result 1. I know at least 1 is here, and then I will say I equals mid plus 1, and while I less or equal to end and the current element is equal to k, I will say res plus plus and I plus plus. So for each element to the right, which is equal k, I will do res plus plus. Then I will say mid minus 1, and while I bigger or equal to start and v of I equals to k, I will add rise plus plus and y I minus minus to go to the left. So if all elements to the right are equal to k, I need this condition to check for that I am still in the bounds of the array, my I, and I check whether the current element is equals to k. And then I just return a res. And these two loops are actually more performant because they don't loop over not equal elements. When they see the first unequal element, they stop.
Okay, so they will not work. Or what?
So what?
You say that these two loops are not performant?
No, they are performant because they don't loop over elements that don't equal k. Comparing to recursion, which jumps it, for example, the k element is in the middle, but then recursion not going middle minus 1 and middle plus 1. It goes
Yeah, it goes to the quarter
yeah, exactly.
and like 3/4.
Yes, and it can take a lot of time before it reaches actual like middle minus 1 and middle plus 1. So that's my solution, but I think I know why they propose in this solution to actually to check you, so you can understand what is going on.
I honestly, I think I didn't fully understand what's going on.
Okay. I need to go just in few minutes, so
Okay.
I will just say that find the worst case scenario. Find the scenario when all M elements are accessed, or like, let's even say that. Find the scenario.
Well, the worst case scenario is when there is no K at all,
No,
and it
you're
will.
wrong.
I'm wrong.
Yes.
Okay, then maybe the worst case scenario then is when all of them are K's.
Yes. That's correct. So,
But I don't know why.
Yeah.
I don't know why.
So try to calculate how many iterations will be, how many elements will be accessed. Let's say that this operation sort of takes one time. Oh, yeah. So you can count.
But it will never be called. It will never
uh,
be called because everything is K.
condition. Okay, let's say the function call is 1. So you need to count the number of times function is called. And you need to calculate it for when there is no case and when all elements are case. And you will understand.
Okay, I will write you.
Okay.
Good then.
See you.
Have a nice evening. See you.